Hello, students of class 10 advanced mathematics. So this is your representation of a complex number in r theta form. So we have already discussed that a complex number can always be represented by a point on the complex plane. If z is equals to x plus iy be a complex number, when it is expressed by the ordered pair xy, which is represented by the point pz in the Argand plane, as shown in figure. Here PM perpendicular to OX, OM is X and PM is Y, and PO, it will be modulus Z, which is equals to root over x square plus y square. We sometimes denote modulus Z by R. This is the distance from the origin to this point. This distance we can denote it by modulus Z or R. It is clearly seen that the point P is uniquely determined by the ordered pair of real numbers r theta. These are called polar coordinates of the point P. Okay, it is clearly seen that the point P is uniquely determined by the ordered pair of real numbers r, theta. These are called the polar coordinates of the point P. Here O is the initial point of the directed line segment OP, on which R increases from O to P. The positive direction of x-axis is the initial line. O is called the pole. Here theta is the angle made by the line OP with the positive part of the x-axis. Now you see cos theta, it will be is equals to x by r. We know cos theta, it is base by hypotenuse. So cos theta is equal to x by r, and sin theta, it will be y by r. So x is equals to r cos theta, y is equals to r sin theta. Therefore, the complex number z is equals to x plus iy can be expressed as z is equals to r cos theta plus I r sin theta is equals to r cos theta plus I sin theta. The representation of a complex number in the form A is called the trigonometric form or polar form of a complex number. Here theta is called the argument or amplitude of Z. It is denoted by ARGZ or AMPZ. Okay. So the representation of a complex number in this form, Z is equals to R cos theta plus I sin theta. If I represent a complex number which is Z is equal to X plus Iy, if I represent this complex number in the form Z is equals to R cos theta plus I sin theta, is called the trigonometric form or polar form of the complex number. This form is called the trigonometric form or polar form of a complex number. Here theta is called the argument or amplitude of Z. It is denoted by ARGZ or AMPZ. Now there is an example. If r is equals to root 2 and theta is equals to pi by 4, then the complex number is r cos theta plus I sin theta is equals to root 2 cos pi by 4 plus I sin pi by 4. It is equals to root 2, 1 by root 2 plus I 1 by root 2. It becomes is equals to 1 plus I. Okay. Next, it is page number 76, argument of a complex number and its properties. So, in the figure 2.8, we have shown that the angle theta is formed by the line OP with OX, where PZ is the point which represents the complex number Z is equals to X plus IY. Here, theta is called the argument or amplitude of Z, and it is denoted by ARGZ or AMPZ, since OP is equals to R, OM is equal to X, and PM is equals to Y, so we can write tan theta is equals to Y by X, from which we can determine the value of theta. Therefore, for the complex number Z is equals to X plus IY, we get R is equal to modulus Z is equals to root over X square plus Y square, and argument of Z is equals to theta, and tan theta it is equals to Y by X. So we can also say that argument of Z equals to theta, where theta satisfied both the equation X is equals to R cos theta and Y is equals to R sin theta. Now note, for any complex number Z is equals to X plus IY, there corresponds to many values of theta which satisfy the polar form of the complex number X is equals to R cos theta, Y is equals to R sin theta. All these values of theta which satisfy the polar form is called the general values of theta. These are discussed in detail in plane trigonometry. Here we are concerned about the principal values of theta only. The value of theta, which is numerically smallest among the general values, is called the principal value. For principal value, we can take the value of theta where theta is greater than equals to 0 and less than 2 pi, or minus pi, or theta greater than minus pi less than equals to pi. But in our discussion, we shall consider the interval theta greater than minus pi less than equals to pi only. Therefore, the values of theta where theta is greater than minus pi and less than equals to pi, which satisfy X is equals to R cos theta and Y is equals to R sin theta, is called the principal value of the argument of Z, or simply principal argument of Z. Here, as and when we mention argument Z or amplitude Z, then it is to be understood that it is the principal argument of Z where theta lies in the interval theta greater than minus pi and less than pi. As we represent a complex number by a point in the argand plane, so it must lie in any one of the quadrants or on any of the axes. When the point lies on any of the axes, then we determine the amplitude of Z as below. So number A, if the point is on the positive part of the real axis, that is along OX, then its amplitude is 0 degree. If it lies on the negative part of the real axis, that is OX dash, then its amplitude is pi or 180 degree. And if it lies on the positive part of the imaginary axis, that is along OY, then its amplitude is pi by 2 or 90 degree. If it's lie on the negative part of the imaginary axis along OY dash, then its amplitude is minus pi by 2 or minus 90 degree. But in case the point lies on any of the quadrant that is not on any of the axis, then the following cases may arise. The student should remember that on the basis of our above discussion on principal argument of Z, we consider the value of theta as shown in figure 2.9b only, but not as given on figure 2.9a. So the above diagram in figure 2.9b will help the student to determine the value of theta. We construct the following table on the basis of figure 2.9b. So first one, Z, complex number is Z is equals to X plus IY, position of PZ, and amplitude of Z is equals to theta. So when X is greater than 0, Y is greater than 0, the point lies on the first quadrant, and theta, it will be greater than 0 and it will be less than pi by 2. Next, if X is less than 0 and Y is greater than 0, that means it is in the second quadrant, point is on the second quadrant, then our theta, it will be greater than pi by 2 and it will be less than pi. And if the point it is on the third quadrant, then theta will be greater than minus pi and it will be less than minus pi by 2. And next, if it is in the fourth quadrant, then theta will be greater than minus pi by 2 and it will be less than 0. Working rule for finding the amplitude or argument of a complex number. Suppose the complex number Z is equals to X plus IY. Then first of all, we calculate the value of alpha from tan alpha is equals to modulus y by modulus x, and also we suppose that amplitude z is equals to theta. Number one. Then for case 1 in table 2.9c, then for case 1, when pz lies on the first quadrant, then theta is equals to amplitude z, it is equals to alpha. For case 2, that is when pz lies on the second quadrant, then theta is equal to amplitude z is equals to pi minus alpha. For case 3, that is when pz lies on the third quadrant, then theta it is equals to amplitude z is equals to minus pi plus alpha. For case 4, that is when pz lies on the fourth quadrant, then theta is equals to amplitude z is equals to minus alpha. Now we already know that a complex number, for example, let's say this complex number z is equals to x plus iy, it can be expressed as an ordered pair xy, and this represents a point on the Argand plane. Okay, this point which is represented by pz. Okay, so that means what? A complex number, we can represent a complex number as a point on the complex plane. We have already discussed that we can represent a complex number as a point on the complex plane or the Argand plane. Okay, so for this example, for example, you see this is the complex number z is equals to x plus iy. Now I can write this complex number as an ordered pair xy. Okay, now this is it represents a point x comma y. It works as a coordinate. Okay, it can be represented as a point on the complex plane. So this is our point, okay, whose x coordinate is small letter x and its y coordinate is small letter y, and this is our point which is represented by pz, and this is the distance from origin to the point. This is the distance, and this distance is denoted by, you can denote this by modulus z or by r. Z is equals to x plus iy, so therefore modulus z is equals to, it will become root over x square plus y square. We have already discussed in previous video. Or you can write it as r is equals to modulus z is equals to root over x square plus y square. Now to represent a complex number in r theta form, okay, that means in polar form, to represent a complex number in polar form, okay, to represent a complex number in polar form, so you see this point is uniquely determined by the ordered pair r theta. This point is uniquely determined by the ordered pair r theta. This will be our theta, is uniquely determined by the ordered pair r theta. So these are called the polar coordinates of the point P. This r theta, it is called the polar coordinate of this point. Okay, so here O is the initial point of the directed line segment OP on which r increases from O to P. The positive direction of x-axis is the initial line. O is called the pole. O is called the pole. Here theta is the angle made by the line OP with the positive part of the x-axis. Okay, so from here, from this figure, I can say that cos theta this is equals to, I know cos theta is base by hypotenuse, so it will be is equals to x by r, and sine theta it will be is equals to, I know it is perpendicular by hypotenuse, so y by r. So therefore x value I will get x is equals to r cos theta and y is equals to r sine theta I will get. Okay, so therefore if I write this complex number, now you see the complex number was z is equals to x plus iy. Now x value is r cos theta. I can write z is equals to r cos theta plus I. This is also r sine theta. So r common, cos theta plus I sine theta. Now if I express a complex number in this form, then it is called the trigonometric form or polar form. Polar form of a complex number. This is called the polar form of a complex number. Now let me tell from the beginning. So we have already learned that a complex number can be expressed as a point on the argon plane or the complex plane. Okay, because let this be a complex number x plus iy. This one I can write it as in ordered pair. I can write it as x comma y, and this x comma y, it represents a point. It represents a point on the argon plane whose x coordinate is small letter x and y coordinate is small letter y. Okay. So if you want to locate this point, this pz, if you want to locate this point, you can use its x coordinate and y coordinate. Or if you want to locate this point another way, you can use the help of this r and this theta. Okay, and r is the distance of this point from the origin, and the theta, it is the angle that it makes, that this line OP, that this line OP makes with the positive makes with the positive direction of the x-axis. Understand? So we can determine this point either by this coordinate or by this r theta coordinate. Okay. So if I express a complex number in polar form, then it becomes z is equals to r cos theta plus I sine theta. This is how we represent a complex number in polar form. Okay. And one more thing here, it is that in here theta is called the argument. Theta is called the argument or amplitude. Theta is called the argument or amplitude of z. Understand? Theta is called the argument or amplitude of the complex number, and it is denoted by ARGZ or AMPZ. Now we will discuss the working rule. Working rule for finding the amplitude or argument. Working rule for finding the amplitude or argument of a complex number. So amplitude of or argument of a complex number, that means we already know amplitude or argument of a complex number. It is the theta. Yes, theta is called the we already know that theta is called the argument or amplitude of z. Yes, let's say this is a point here. It is represented by pz. Now if I join OP, so this will be our theta. Yes, it is the angle that this line OP makes with the positive direction of the x-axis. This is the theta, and this theta, I will say it is the argument of this complex number z. Now how will you find the value of this theta? This is the working rule for finding the amplitude or argument of a complex number. So first of all, suppose there is a complex number which is z is equals to x plus iy. Suppose this is the complex number. Then first of all, we will calculate the value of alpha. Okay, from I will write 10 alpha is equals to modulus y by modulus x. Okay, and also we suppose that amplitude z is equals to theta. Okay, so then from here I will get the value of alpha. And after that I can calculate the value of theta. So theta is equals to our become amplitude of z is equals to alpha if pz lies in first quadrant. Okay, this one you will have to remember. Theta, it will be is equals to alpha if pz, that is the point, it lies on the first quadrant. And theta is equals to, this is amplitude of z, it will become pi minus alpha if the point lies in second quadrant. Okay, and then next it is theta is equals to amplitude z, it will become minus pi plus alpha. If pz lies in third quadrant. And theta is equals to amplitude z, it will be is equals to minus alpha if pz lies in fourth quadrant. Understand? So this is how we will be able to calculate the amplitude or argument of the complex number. That is how we will calculate the theta. If the point lies in the first quadrant, we know that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. If the point lies, okay, now we have already discussed that a complex number, I can express it as a point on the complex plane. So if the point lies in the first quadrant, then our theta, it will be is equals to alpha. And alpha, how I will calculate? 10 alpha is equals to, it will become modulus y by modulus x. Okay, from there I will get the value of alpha. And next it is, if the point lies in the first quadrant, then our theta, it will be is equals to alpha. And if the point lies in the second quadrant, then theta, it will be is equals to pi minus alpha. If it lies in the third quadrant, then theta will be is equals to minus pi plus alpha. And if it lies in the fourth quadrant, then theta, it will be is equals to minus alpha. Okay. Now next we will solve some examples here. So now in here you see example 1, it is given. Example 1, it is given that Determine the modulus and the amplitude of each of the complex numbers given below. Okay, determine the modulus and amplitude of each of the complex numbers given below. So it is first, it is given 3i. Determine the modulus and amplitude of each of the complex numbers given below. So now you see solution. I have to determine modulus, the modulus and the amplitude modulus and the amplitude. Okay, so in here you see z is equals to our 3i there, which I can write as 0 plus 3i. So modulus of z, it will be is equals to root over 0 square plus 3 square, which will be is equals to root over 0 plus 9, root over 9, which will be is equals to 3. Okay. And next it is I have to determine the amplitude of z. I have to determine the amplitude of z. Amplitude of z, it will be is equals to, you see this is 3i, 0 plus 3i. That means the complex number lies on the positive part of the imaginary axis. Yes, it lies on the positive part of the imaginary axis. Now one thing I skipped here. One thing you see I skipped here. You see in here as it is saying, as we represent a complex number by a point in the Argand plane, so it must lie on any one of the quadrants or any of the axes. When the point lies on any of the axes, then we determine the amplitude of z as below. If the point lie on the axis, okay, if the point is on the positive part of the real axis, then the amplitude is 0 degree. If the point lies on the negative part of the real axis, then its amplitude is pi or 180 degree. If it lies on the positive part of the imaginary axis, then its amplitude is pi by 2 or 90 degree. If it lies on the negative part of the imaginary axis, then its amplitude is minus pi by 2 or minus 90 degree. Understand? But in case the point lies on any of the quadrant that is not on any of the axis, then the following cases may arise. Understand? If the point lies on any of the quadrant, then we will follow this rule. In case the point lies on the first quadrant, then our amplitude will be pi. It lies in the second quadrant, then it will be pi minus alpha. If it lies in the third quadrant, then minus pi plus alpha. If it lies in the fourth quadrant, then our amplitude will be minus alpha. Now you see this point, which is 3i, which is 0, 3. Yes, if this complex number, if I express it as ordered pair, 0 plus 3i, if I express it as ordered pair, I will get what? 0, 3. So 0, 3 means what? This point, it lies on the positive part of the imaginary axis. It lies on the positive part of the imaginary axis. Understand? The point lies on the imaginary axis. Then our amplitude will be pi by 2. You see the amplitude will be, if the point lies on the positive part of the imaginary axis, then its amplitude is pi by 2 or 90. Okay. So as this point lies on the positive part of the imaginary axis, so our amplitude will be pi by 2. Okay. So in here I can write, since the complex number lies on the positive part of the imaginary axis, imaginary positive part of the imaginary axis. Therefore, amplitude of z, it will be is equals to pi by 2. Okay. Next again you see, next again it is given number 2 minus 4i. So in here solution z is equals to minus 4i, which is I can write as 0 minus 4i, 0 minus 4i, or you can write it as 0 plus minus 4i. You can write it in this way, 0 plus minus 4i. So you see, this is, if I express this complex number in ordered pairs, I will get 0 comma minus 4. I will get 0 comma minus 4. Okay, first of all let me calculate the modulus z. Modulus z, it will become root over 0 square plus minus 4 the whole square. This becomes 0 plus 16. This is root 16, so this becomes 4. Modulus of z is 4. Modulus of z, that means the distance, this is your complex plane, sorry, this is your complex plane x o x dash and y o y dash. So this is, you see, minus 4i, so it lies on the negative part of the imaginary axis. Yes, it's ordered pair. It will be what? It will be 0 comma minus 4, 0 comma minus 4. So this point, where it will lie? This point, it will lie on the negative part, 0 comma minus 4. It lies on the negative part of the imaginary axis. Understand? And amplitude z, this is 4. That means it is the distance. It is the distance from the origin to the point. It is the distance from the origin to the point p comma 0. Distance of the origin from this one, this distance, OP distance. This is our modulus z. Understand? And in here, since the complex number lies on the negative part of the imaginary axis, so therefore amplitude of z, it will become, you see, if the point lies on the negative part of the imaginary axis, if the point lies on the negative part of the imaginary axis, then amplitude is minus pi by 2. So therefore I can say amplitude of z, it is equals to minus pi by 2. Understand? So next, you see, question number 3 you try to do by yourself. I will show you question number 4, 1 plus root 3i. Okay, 1 plus root 3i. So solution, z is equals to 1 plus root 3i. So modulus z, it will become 1 square plus root 3 the whole square. So this becomes 1 plus 3. This becomes 4, and this is modulus z, this is equals to 2. And now you see, z is equals to 1 plus root 3i, which is equals to, I can write 1 comma root 3. Now the point you can say the point P 1 comma root 3, or you can say the point PZ um, lies the point lies on the this will be this point, it lies on quadrant. Okay, since point PZ lies on the uh, first quadrant, so to calculate the argument of Z, first of all I will have to find tan alpha here. Tan alpha is equals to modulus x. Okay, so this one is equals to modulus 1. This one is equals to root 3 by 1 I will get. So tan alpha is equals to root 3. Root 3 it is, I will get in tan 60 degree, or I can write in place of 60 degree I can write pi by 3. I can write root 3 pi by 3, because 180 divided by 3 will get 60, so pi by 3. So alpha is equals to pi by 3 you will get. Understand? So therefore uh, tan theta, so theta is equals to pi by 3 I will get. So therefore you see amplitude of Z, you see here it is given, if the point lies on the first quadrant, then amplitude of Z, it is equals to alpha. Yes, so therefore I can write amplitude, it is equals to alpha, so which is equals to pi by 3. Understand? Which is equals to pi by 3. Pi by 3 you can write, or 60 degree you can write. Understand? Pi by 3 you can write, or 60 degree you can write. So this is how we calculate amplitude or argument. Understand? Amplitude of Z or argument of Z. Okay. So rest of the problems you try to do by yourself. If any problem you will get, you please write it in the comment section. So next, example 2 there, represent the complex number Z is equals to minus 2i in polar form. Okay, r theta form means polar form. This is our example 2 there. Example 2, it is saying that represent the complex number Z is equals to minus 2i in polar form. Okay, in polar form. R theta form means polar form. Okay, so to express this complex number in polar form, first of all I will have to find modulus of Z. Okay, polar form, this is minus 2i there. That means this following point, first quadrant both are positive, second quadrant this second quadrant it is like that, this is first quadrant, second quadrant it is like that, fourth quadrant it is like that. So the following point lies on the third quadrant. Understand? Fourth quadrant it is in this form. So the second, this complex number, it will lie on the third quadrant. Okay, so first of all Z is equals to minus 2i given. Okay, so in here first of all I will take let Z is equals to this one you can write as minus 2 plus I dot minus 2, which is you can write it as r cos theta plus I r sin theta. this equals to r cos theta plus I sin theta. So now r is equals to, we know, modulus z, which is equals to root over minus 2 the whole square plus minus 2 the whole square. So this our becomes 4 plus 4 is equals to root 8, and root 8, which is, you can write 2 root 2, and then the next one, um, 10 alpha is equals to y modulus y by modulus x, which is equals to minus 2 modulus by minus 2 is equals to 2 by 2, which is equals to 1. So 10 alpha is equals to 10 theta 1 becomes, when it is 1045 degree, 1045 degree to 1 becomes, so 1045 I can write it as pi by 4. Okay, so this gives me alpha is equals to pi by 4. This gives me alpha is equals to pi by 4. So now you see, example 2, represent the complex number, z is equals to minus 2i in the r theta form or polar form. Okay, I have to represent this complex number in polar form. So first of all, in here you see, I will take let z is equals to minus 2i, which is equals to, I can write it as minus 2 plus I minus 2. So it becomes is equals to r cos theta plus I r sin theta, where r is equals to modulus z and theta is equals to amplitude of z. Okay, remember I am writing this complex number in polar form. Okay, so now r is equals to modulus z, which is equals to root over, it becomes minus 2 the whole square plus minus 2 the whole square. So this becomes is equals to root over 4 plus 4 is equals to root 8, which gives is equals to 2 root 2. Okay, it gives is equals to 2 root 2. Next again, I will have to find alpha. So 10 alpha is equals to modulus y by modulus x. Y is minus 2 here, so modulus minus 2 by modulus minus 2, which is 2 by 2, which is 1. So 10 alpha is equals to 10 alpha, 10 theta 1 becomes, when theta is 45 degree. So 10 alpha is equals to 10 45 degree. 45 we can write, or we can write let me 45 degree we can write, or pi by 4 we can write. Okay, because 180 by, if you divide it by 4 4s are 16, you see 45 I get. So therefore 10 pi by 4. This gives alpha is equals to pi by 4. Understand? Alpha is equals to pi by 4. Okay. Now I will write uh, you see, clearly z is equals to minus 2I, which I can write as minus 2 comma minus 2. Okay. So um, the point represented by the complex number, the point represented by the complex number lies in the both x and y minus minus there. That means it lies in the third quadrant. It lies in the third quadrant. So therefore theta is equals to amplitude of z in third quadrant. In third quadrant, you see, in third quadrant, theta is equal to amplitude z. It is minus pi plus alpha is equals to minus pi plus alpha. So this becomes is equals to minus pi plus pi by 4. So this one, if I solve it, I will get minus 3 pi by 4 I will get. Understand? Theta is equals to, I will get minus 3 pi by 4 I will get. So now I can say, so now you see, therefore the polar form, of uh, minus 2I is polar form. It will be, you see, it is r cos theta plus I sin theta, r cos theta plus I sin theta. So r value I have got 2 root 2, r value I have got 2 root 2. So therefore the polar form is 2 root 2 cos theta. In place of theta I will write minus 3 pi by 4 plus I 2 root 2 sine minus 3 pi by 4, which is equals to, is give me 2 root 2. This is cos negative theta, it is cos theta only, cos 3 pi by 4 plus I sine negative theta, it becomes minus sine theta. So minus sine 3 pi by 4. So this is our polar form. This is our polar form of this complex number, minus 2 minus 2I. Okay, so this is how we represent a complex number in r theta form or polar form.